All right, guys, this might be the shortest lesson I've done yet, or the shortest video. So this was an introduction to circles. My hope is you remember this from analytic geometry, but if not, that's okay. This kind of stands alone. So we're going to derive the equation of a circle just using either the Pythagorean theorem or the distance formula, which really are one and the same. So for example, you see the circle drawn in front of you. You see that the center of the circle is called HK. So the center of the circle is HK. XY represents any point on the circle, so that's crucial. So I just plopped a point on the circle, called it XY. Now, the distance from the center of the circle to any point on the circle in this picture is C. Okay, so I'm going to write the Pythagorean theorem based on what you see drawn here. So I have let's try that again. So I have A squared plus B squared equals C squared. Okay, so we've coordinatized a circle. We have a circle floating out in space. So I know that A squared plus B squared equals C squared. C, of course, is the radius. So C and R in this problem will be the same. So distance A is, so H is my X value for the center, and X is my X value for representing any point on the circle. So A can also be written as X minus H. Okay, let me give you an actual example. So let's say H is 5 and X is 7. How far is H from X, or how far is X from H? It's 2 spaces, 7 minus 5. So we would say that A is 2. So A in this problem is the same as whatever that value is minus whatever that value is, X minus H. So I'm going to replace the A with X minus H, and this is actually a proof of the distance formula, which you saw back in 8th grade, maybe 9th grade. All right, and similarly, B is Y minus X. So I'm going to replace the B with Y minus, I said X, I meant K. Y minus K. I'm still learning my alphabet. And that's going to equal C, which in this picture, C is the same as the radius, so I'm going to call C R. So we see that this formula comes literally straight from the Pythagorean theorem coordinatized. So we just dropped a circle, we built a right triangle, and we derived the formula. So this is the standard formula, standard form of a circle, where H and K represent the center, where X and Y represent any point on the circle, and then R represents the radius. So I just wanted to kind of show you that. I thought that was cool. That's actually in the analytic geometry study guide for the end of course test, this proof. So it's kind of cool. This is something that we should show you, but a lot of times we don't. Okay, so given any circle, so now I'm going to coordinatize, given any circle, center HK, we can of course find any point on the circle. That's going to represent just some point XY, the radius is R. So given any circle centered at HK, the equation of that circle will be X minus the X coordinate of the center squared plus Y minus K, the Y coordinate, and that will equal R squared, where HK is the center and where R is the radius. Okay, so my hope is you've seen this before. If you have not seen this before, there it is. I'm going to do one example, and then I'm going to throw you to the wolves. Told you this was the shortest video ever. So let's do one example. So let's build the equation for this circle. I know the center, I know the radius, I know that XY represents any point on the circle. So the equation will be X minus 4 squared plus Y minus 5 squared equals the radius squared, which is for final answer. Okay, so I do want to draw your attention to, in the equation, the radius is squared. So if I'm given an equation, I have to think backwards. The square root of 4 is 2. So sometimes the radius is not a rational number. So if this 4 were 10, the radius would be the square root of 10. Similarly, okay, another kind of thing you have to be careful of. In the equation, when you see minus, that means the coordinate is positive. If you saw x plus 4, that would mean the x coordinate of your center is negative. Similarly for k. Okay, so the equation negates h, negates k, squares r. All right, guys. Bow. So that's the first page of those 3 pages. Now I want you to, on your own, try 1 through 6. You have every piece of necessary information to try 1 through 6 to the best of your ability, and you have an embedded link on page 2, this YouTube video. Only watch the first 3 minutes, okay, if you need to. If you watch the first 3 minutes of this, it will explain 1 through 6 and how those problems work. All right, guys, have at it. I will see you guys next week. Have a great weekend. Be safe.